We are going to continue with object-oriented analysis and design. So last time we were discussing about in general what are the two approaches in analysis and design, and of course analysis, design and programming. Okay, so we discussed that there are two approaches, the key approaches, the structured approach and object-oriented approach. Okay, the structured approach and the object-oriented approach. We discussed that in structured approach it is all about process and data. Data is process, and when it comes to data we have to model and understand data, like what are entities, what are relationships, etc. And of course the process we have to understand. So there we discussed that in analysis we can use context diagrams, level 1 data flow diagrams, level 2 data flow diagrams, etc. And also in designing, again we can go for the design ER diagram like normalization and other concepts. And when it comes to design in the process part, we can go for modular decomposition. And we discussed that there are two very important concepts when it comes to modular decomposition: the cohesion and coupling. So high cohesion and low coupling is preferred when it comes to modular decomposition. Okay, so we have to modularize so that we can develop them independently, and also there will be some sort of a reusability. Though the structured approach is not as reusable as object oriented, if you do a proper modular design, at least we can get some sort of a reusability. Okay, so that is what we discuss in that side, right? So then we moved on to object oriented analysis, design and of course programming. So there we discussed that we think in terms of objects. That is why we say object oriented approach. So there again we have to do the analysis in object oriented manner, design and of course develop. And so we have done how to do object oriented programming under your programming subject in semester 1. So therefore we have already discussed this, and of course together with bit of design, but we were in a somewhat quick revision on what we have covered in the semester 1. Okay, so we discussed that. Still we are in that quick revision, okay, because we have discussed those things in the semester 1. We discussed that when it comes to object oriented analysis, design and development, we think in terms of objects, and we identified two main concepts or object oriented basics. Those are the concept of object, and of course highly related thing but some different thing as well, the concept of class. So they are not the same but highly related. So then we discussed the concept of messaging or message. So those are the two basic concepts that object oriented thinking behind the object oriented programming, object oriented analysis, design is all about. Okay, the concept of object and of course class, the concept of messaging, and we discussed that. Okay, we discussed that. Of course, then we discussed that we'll get back to this because we were in that discussion last time. Okay, so today we are going to do few more points related to this. Then we are going to discuss the other things, object oriented concepts. So these are just the basics. Okay, that is abstraction. So a lot of students say inheritance and polymorphism, forgetting the first two. First two are also important: abstraction, encapsulation, inheritance and polymorphism. Okay, so we were discussing about object and of course the concept of class and messaging. Okay, so when it comes to object oriented programming, we think of, right, that is fairly correct thing. We can think of a system as set of objects, or these objects can be of different types. They communicate and collaborate with each other. So then by doing that, they are doing certain things, so achieving certain things. So those are the business processes, uh, etc. in of the organization or the aspect that we are looking at. So the result of this may ended up processing some orders, processing some payments, processing some dispatch of goods. Okay, maybe if it is sort of that kind of a selling oriented business organization, or it can be a student is registering for a program, then the student is doing the payment, right? Of course the student is getting access to the online materials, online sessions, etc. It's again, we can think of it as set of objects interacting and of course communicating and interacting. Okay, so as a result of those interactions, of course, students are getting registered, the courses are progress, right? Lectures are conducted, maybe exams are done, conducted, and the results are released, etc. Okay, so it's very important that we have to look at our system in this way, because there's no other way. Then only you are thinking in terms of objects and messages, right? Objects and messages. At beginning it's somewhat difficult, right? But once you get used to it, you will find that this approach is very natural. Okay, very natural. Actually the somewhat unnatural thing is the structured programming. Okay, right. And of course we discuss what is mean by what are the two things that we are interested in objects, right? So what are the two things we are interested in objects? Attributes and behaviors. Right? Attributes and behaviors. Why? Attributes are the data that we are interested in that object. Behaviors are the processes or services of that object. Okay, yes, we are interested. So in structured programming, these attributes or data and these behaviors or processes were separated. So that is why we call it data plus process approach. But in object oriented analysis, design and development, every object has, right, every object has both attributes and behaviors, so data and logic. Okay, so that is the main difference between the thinking behind structured analysis, design and programming, and the thinking behind object oriented analysis, design and development. Okay, so the objects have both attributes and behaviors bundled together. Okay, and so then we discuss about the concept of class, right? Concept of class, because we are supposed to draw some class diagrams, sequence diagrams, etc. later on. So if you don't know exactly what is a class, right, it's never going to happen that you are going to understand what is a class diagram is, what is sequence diagram is. Okay, right. So what is a class? So now since you are following IT degree, and some of you want to seriously move into IT field, so when it comes to a definition like what is object, what is a class, what is inheritance, what is polymorphism, right? You have to be very serious. Okay, right. So therefore, don't give some answer and satisfy that. Okay, I know the concept. You have to question yourself: am I having the best answer? Okay, am I having the best answer? Am I having the simplest answer? Okay, so if you have the best simplest answer, that is where you have achieved your objective, because otherwise you will not be that serious about that concept. Okay, right. So what is a class? We can, our answer must consist of two key points. A class can act as a blueprint, C level, or factory to create objects. That is number one. Okay, class act as a blueprint or factory. Actually that is number two. Basically the number one is, right, number one part, the more key point when it comes to class is a class represents or models, right, or represents set of same objects or similar objects. right? So in order to represent all the customer objects, we have the customer class. To represent all the payment objects, we have the payment class. To represent all the accounts, we have the account class. So likewise, right, to represent all the students, student class. To represent all the courses, course class, right? And of course, to represent all the attending or attendant objects, we have the attendant class. Okay, attendance class. Okay, so likewise. Okay, right. So therefore we don't have to model each and every object separately, because if it is a banking system, there can be thousands of uh, accounts. Okay, if there's a supermarket or something, thousands and thousands of uh, orders are processed, payments are done. So therefore, what we need is a way to model all these similar or same objects, right? So that is called class. Okay, right. So that is very important. So every programming language provide a way to create objects out of class, right? For example, if it is Java, if you create a class called account, right? So then you can say account, say a equal new account. Okay, so that can be done, okay. If it is PHP, because it's a weakly type language, still you can say a equal new account. Okay, right. So that is the idea behind a class. Okay, class represents or models set of similar objects. Okay, and also it acts as a factory or blueprint to create objects, right? So that is number one. Okay, right. So number two is, right, messages. Okay, now remember, objects have attributes and behaviors. That means class also have attributes and behaviors. Okay, class also have attributes and behaviors. Just because a class have attribute behaviors, it doesn't mean that an instance of that class or object of that class is going to be useful. So they have to, those objects have to or those objects behaviors have to be called. And of course, when some business process triggers a behavior of object, sometimes or most of the time that behavior will not, or the behavior itself is not going to do the task. It has to get some help from other behaviors, or the behaviors of other objects, or maybe behaviors of the same object. So that is what is known as messaging. Okay, what then someone, if someone asks what is messaging, you have to say it is object calling behaviors of another object, right? An object calling or invoking behavior or getting the service of another object is called messaging, right? Messaging, right? For example, so say my customer object can message the account object to do some deposit, right? So something like that. Maybe that deposit object or the account object has to get some help from some other utility object. So likewise, it's a collaboration and communication of set of objects that does the work, final business transaction. Okay, business process. So that is very important, right? If you have even a slightest doubt about those statements, you have to clarify those things. Okay, you have to ask questions and clarify. Okay, right. So let's demonstrate this. Okay, let's demonstrate this, because it's all about practical. Remember, we have two objectives when it comes to object oriented analysis and design, right? Of course, the number one is we want to make sure that you have that courage and confidence and competency on object oriented analysis and design. Okay, that confidence, right, that competency, that courage on, or the confidence on object oriented analysis and design. And of course, that is our number one. Number two objective is, of course, we want you pass in the exams. Okay, right. So therefore, for both the reasons, right, these both the reasons are highly related. Therefore, if you are achieving the first one, most probably you will be achieving the second one as well. Okay, right? But not the vice versa, right? But not the vice versa, right? So now let's demonstrate this, right? So the very basic of the concept of account, so concept of class, object, and message passing. Okay, so we are going to use these examples when we are doing class diagrams, when we are doing sequence diagrams, communication diagrams, etc. later. Okay, so I'm using IntelliJ. Okay, I'm using IntelliJ. Okay, so let's call this. Did I do this last time? No, I don't think. Let's double check. Okay. No, we haven't done that. Okay, right. So let's do it. File, new project. Right. So we have to give it a name. We'll call it SEM 3 OP revision. Okay, so let's create a class. Okay, I'm going to make it a very abstract example. Okay, so let's do something like this. Okay, so let's make it very abstract. Okay, so let's have two classes called A and B. So when I say abstract, it is not abstract class. We want to make it very non-concrete sense, very general scenario. Okay, right, so I'm going to have another class. I'm going to call it B. So that means there are in the system there must be some proper objects of A nature, some other objects of B nature. So that is why we have A class and B class. Okay, right. So let's say A class has some properties. Okay, properties. So attributes. Okay, say int A1, int A2, right? And maybe few methods. Say void A behavior 1. Of course we are not doing anything, but we'll do something like this. System out println. We will just write a small message saying A behavior. Let's make it capital. A behavior 1. So similarly we are going to say let's have output something like this, just to make it doing something. A behavior 1. So let's say we have another behavior. Say B behavior. Let's say B behavior. Okay, so my class A. Now let's say I have class B. So I'm going to do the same thing. I'm going to just copy paste for class B. Right, so let's call two properties they have, B1 and B2. And let's say we have a B behavior 1, B behavior 2. Okay, B behavior 2, B behavior 1, B behavior 2. I won't double check whether it's the same with A also. I think I made an error. Yeah, so this is A behavior 1, this is A behavior 2. Right, A behavior 2. Right. Okay. So now we have two classes. Now let's create a test class. Now let's create a test class. Let's call it test A, because assume that A is the main functionality that is more related to us. Of course, when it comes to unit testing, there are some frameworks like JUnit, etc. But we are not going to that kind of sophisticated testing framework. Let's say we are just doing a testing using the main method. Okay, public set void main. Okay, now I can create A objects or B objects. So let's create A objects. Okay, A objects. Of course, I know that there are two ways. There's a way to create A objects. That is, of course, you can't see any constructor here. So that means the default constructor is available. Okay, so there is no argument constructor. So likewise, every line you must be able to explain with a lot of confidence. Okay, every line, because this is not semester one. Okay, right. So now my class, okay, now I create a test A. I'm going to create an instance of A. Let's call it A1. New A. Now this is my main method is now calling, now has created a instance. So usually why we want to create instance of a class or instance, because we want to invoke some behavior, so we want to see their properties. Okay, those are the two main reasons: invoke, call behaviors, read those, change the attributes. Okay, right. So now we have the A type A object. Now let's say my A1 dot, we are calling the A behavior 1. Okay, A behavior 1. So that is, so this is something like this. So let's understand class diagrams, sequence diagrams, etc. right here, not waiting until we are doing the diagrams. Now what we do here is, say we have first, we have the main, object, or the main method, or the main behavior of, right, main behavior of test A class. Okay, main behavior of test A class, but this is basically a test A class. Right, test A. Now with this, now this test A is creating an instance of A type, right, and it's calling the A behavior 1. Okay, A behavior 1. A behavior 1. So don't worry too much about the exact details I'm drawing, but this is definitely test A class. This is A class. Okay, now you can call A behavior 1. A behavior 1. That is message passing. Okay, so my test A class, okay, my test A class create an instance of a class and call in the A behavior 1 method or the behavior. That means we are sending a message to A instance, calling it to, asking it to show the A behavior 1, or give that service of A behavior 1. Okay, and of course we have the A behavior 1. Okay, so it's doing something very simple thing, and just give a system out println, right? It's printing something. But now assume that this A behavior 1 can call, as part of doing this task, A behavior 2. It's very easy, right? Assume that we need that, because A behavior 1 feature need to do A behavior 2 feature, right? For example, if it is something like, say you are object of a human, and you are object of a human. Now someone asks you to have lunch. ඔයාට ආරාධනා කරනවා කියලා ගන්න. හරි. ඔයාට කියනවා කවුරු හරි let's have lunch. Now of course now that person is calling the have lunch behavior of you. Now maybe when you want to have lunch, first you want to wash your hand. That is again a behavior of you, right? So this is something like this. When you want to do this, you want to do the other thing as well as part of this one. Okay, so how to show that? It's very easy, right? So you can say it's something like this. Again, because that behavior is again with about you, but the behavior is now here the A behavior 1 was called. Now A behavior 2 is called. A behavior 2 is called, but still in the same object. Now let's assume that as part of A behavior 2, now I want to it want to get the help of B behavior 1, right? B is B behavior 1. Now as part of this task, as part of this particular behavior, in order to do this behavior, in order to get this done, we have to get the help of B object of B class, and we have to tell them that okay, please show the B behavior 1. So then only I can proceed with my A behavior 2. Okay, right? So now you have to think, because you have done object oriented programming in semester 1. Okay, semester 1 with lot of advanced concepts like thread programming, JDBC, UI programming, right? So many things like file handling, database handling, of course object oriented basics, advanced, etc. Okay, right? So now as part of showing this A behavior 2, right, now my it has to call the B instance of B class B behavior 1. Okay, let's call the B behavior 2. Now how to show that, or how to first, let's see how to implement that. Of course we can easily show it. So that means, so we have to, I'm explaining very serious stuff. Okay, if you can understand this, you are going to understand the rest of the stuff. Okay, so now of course it call the, say let's call this 1, this is 2. Now it has A behavior 1 has called the A behavior 2. Now A behavior, after A behavior 2 is called, now it has to create an instance of B class, and we have to call the B class B behavior 2. Let's assume, okay, B behavior 2. Okay, B behavior 2. Now you have to come up with a plan and design, if possible. Of course this is if you have already thought about these things, how are we going to do this, right? So you have to talk now. So as part of A behavior 2 methods task, it has to call the B class objects B behavior 2. How to do that, right? So think about it. लोग कहते हैं सॉफ्टवेयर का डेवलप करना क्या, डिजाइन करो. So if you can answer me my question, that means you have a very good idea of object oriented programming. Okay, right? Think about it. I give you 1 minute. Now it's 8:1. You can answer only after 8:2. Okay, right? Think about it. So don't give me the answer, because then others' chance is lost until I ask you to give the answer. Right, so you have to explain me in very precisely, at the same time short manner, how are you going to achieve this in your coding level, right? Anyone? So then I'll accept that you have a good idea about object oriented programming. practically. Just because you know what is inheritance, what is polymorphism, what is encapsulation, or even what is object-oriented programming, it doesn't mean that you are a good practical software developer. You are just good in your theory, that's all. So now you have to come up with a solution. How are we going to do that? So as part of this A class, A behavior 2, it has to call the B class instance B behavior 2. Okay, how to do that? How to implement that? That is my question. Takara kiyanno na? Vela ganna nathu. Now we are calling A behavior 1. A behavior 1 is calling A behavior 2. That is fine. But here, this is where I am expecting to call the B class B behavior 1. Or sorry, B class B behavior 2. How to do that? Right. ඔගොල්ලෝ proposal එකක් දෙන්න ඕනේ. මෙහෙම කරමු කියලා. ඒකෙන් හොඳම උත්තරේ පස්සේ හොයමු. දැන් මට ඕනේ නැහැ perfect, but I need some sort of answer that you feel like that is going to work, or that is the best I can think. How to do this particular, if this particular task is the next step, how to show it in your, or how to implement this basically. So then I will accept that you have a very good idea about the object-oriented, with the basics of object-oriented programming. Anyone or no one? So don't hesitate to make mistakes, right? Because this is learning. If you are perfect, right, you don't have to attend classes, right?
We had to make B behavior 2 public.
Sorry, first we have to make B class public. Is that the first point?
Yes.
Okay, so B class is already public. What else? What is the next?
Import the B class.
Import the B class where?
To test A.
To test A. Okay, then that means here you have to import B. So import, yeah, B. Why I'm not getting, why I'm getting error? Okay, it says no need. It says no need because B is in the default package. You all are in the same package. It says no need. Now in the, when someone call A behavior 1, it will be calling the A behavior 2, and the A behavior 2 is going to call the B behavior 2 of the B class. How to implement that? If you can explain it, you know message passing. Any answer?
Input behavior 2 will create a new object of B. Then
Where do we want to create the new object of B?
inside the behavior 2.
Inside E behavior 2. Okay, so just wait. So that means I am going to create a B. Let's say B equal new B. Okay, I hope that is what your expectation. Okay, then what I am supposed to do?
Then we call this method B behavior 2.
Then you call B dot B behavior 2. Right, others, do you agree with that, or do you not agree with that? because it must be a discussion, right? Now you are not level 1 anymore, you are level 2. You are matured, you are filtered now. Others agree with this, or they think that there's a better way of doing this. Or you are not very sure whether to agree or not. Okay. So anyone wants to give a feedback? At least you can say, yes, I agree. I think this is the way to go. Or you can say, no, I feel like, sorry?
I agree.
Okay, you agree. So you agree that this is the way to go. Okay, right. So this is one possible way to go. Right. So this is what I will say. This is possibility one. Possibility one. Okay, that is in your A behavior 2 method. You create instance of B and call the B behavior 2, because what we need is call in the B behavior 2. Okay, yes, that is one possibility. Okay, this is one possibility. Okay, right. There's another possibility. Can someone tell me or guess, using your object-oriented knowledge, your exposure, experience during semester 1 or after the exams, can you think of another possibility of doing the same thing? So this is okay. This is okay, but there's another approach. Somewhat slightly different from this approach, but fairly related, but slight difference is there. What is that second approach? Right.
Make that B behavior to public, that method public, we can
So
directly call.
no, yeah, but the thing is that has to be done by. So assume that this is a business requirement, right? So the test class cannot directly call it. It has to call the B behavior one. Then because this is how the business logic work. This is how the business process is supposed to happen. So therefore, you are not supposed to do that. It must be. Other party calling the B behavior 1 and B behavior 1 calling the B behavior 2, and B behavior 2 must be calling the the other third party calling the A behavior 1 and A behavior 1 calling the A behavior 2, and A behavior 2 is the one that is supposed to call the B objects B behavior 2. So therefore this is some sort of a business process. So therefore I don't want to take that as answer because I have a restriction now. Again I'm telling, this is one possibility, but there's another possibility, and the other possibility is more frequently used than this possibility.
We can create a B object inside the constructor method. So we can pass this one as a
Yes, so that is so that is exactly the second possibility, and usually most of the software developers will be using this second possibility. That is, don't create that object here, right? Don't create that object here, the B object. Rather, either you can do it in the constructor of A, because A need the help of B. Now you can see that A need the help of B, right? A need the help of B because A need to call the B behavior 2 of B. So therefore it's always good, most of the time, have a B object as a instance variable. Say B, let's just call it B as a instance variable, because then all the methods have access to that particular object, right? Otherwise, if another method need to get that, call the behavior of another behavior of the same behavior of the B object. That method again has to create object. So that is unnecessarily you are creating too many objects, right? So everything has a reason. This is formal logic, right? So everything has a very distinct or very realistic reason. Okay, so now then of course maybe in 2 or 3 methods you are creating objects of the B. So now if you go to this approach, right, now of course still the object is not created. Right, now we can create the object in 2 ways. One way is we can create the object in the constructor, right? Now here you can create this object and let it revert by the B, new B. So that is one approach. Then of course then of course here you can just call it, right? So you don't have to create the object in the behavior a behavior 2. Okay, and this is preferred as well. Okay, why we prefer? Assume that maybe I have another behavior called a behavior 3. There also you want to call the something called b behavior 3. Now again you have to create object, right, if you create objects in the method. But if you do go to this approach, all the object is available to me. I can just call the b behavior 3, right, because b is already created once, right? So usually this is the better approach. Okay, right? So I'm explaining you very serious stuff, right? So next time we are going to discuss something like use case diagrams. Those are not at all serious stuff. This is the serious stuff I'm explaining. Okay, related to class diagrams, sequence diagrams, and of course those are the things that drive your design. Okay, right? So now I prefer the second approach. Okay, of creating instance variable of B. But if you are now, this can be done in even a slightly different manner also. That is, if you want, you can just get rid of this constructor line and you can straight away create the object here also, something like this. So this is exactly the same as this behavior of this constructor, right? So therefore most of the time what we do is usually we go for this kind of approach. We create the object as an instance variable, we declare it and we create the object in that level, not within the constructor or any other method. Okay, so then it is available to any of the methods as long as this is not private. Okay, right, I hope you got it, right? So we are now explaining the design aspect and we explain how to code that. Okay, or sometimes how to code it, the code, and we try to understand what is the design. Okay, whatever the way, you must be able to understand, whatever the way. Right, so this works when you know, right, when you know where are you going to need the objects. Of course, if it is actually, you don't have to worry where are we going to need the object. Basically you must know that, okay, we need these B objects because we are going to call some of the behaviors of B, maybe in one method or maybe more than one method. Okay, right, so now this is explained. Okay, this is explained. Okay, so now if after doing this, that means after A, right, after A calling the A behavior 1, of course it is calling the A behavior 2 as well. Now right, now it want to recall the B behavior 3 as well, right, B behavior 3 as well, but it is done by A behavior 1. Okay, so now this is my sequence diagram. Once you get this, now I'm going to make it a little bit longer. I'm going to make it a little bit longer. Okay, so that means there's no such line. Okay, so now A has to call the B behavior 3 according to this requirement. Okay, behavior 3. Okay, right, now let's do that. So that has to be done by the A behavior 1. So after doing this, now you are supposed to call B dot. So of course my B class doesn't have B behavior 3. Let's add it. B behavior 3. Okay, right. So now my A class, A behavior 1, because this is A behavior 1, now it has to call the B object. So of course I have the access to the B object, which created at the beginning of the creation of the A class. Now I can call B behavior 3, and now I am done. So this is my sequence diagram, and this is my code. This is my code. Okay. Right. It's very important when you are given a diagram, sequence diagram like this, you must be able to write the code. When you are given a code like this, right, you must be able to draw the sequence diagram. Okay, sequence diagram. So I hope you got it. And in a way, I gave a gentle introduction into sequence diagram. At the same time, I gave you a introduction into the how the message passing is working, right? In a way, we are learning how the message passing is working. On the other hand, we are learning the basics of sequence diagram. Okay, sequence diagram. Okay, any questions up to this point? No? Right, so then I am going to give a brief introduction into class diagram as well. Right, class diagram as well. A class diagram is again mostly used in designing and sometimes analysis, but mostly in designing. This one is mostly in designing, but sometimes it can even be in analysis. Okay, right. So now we want to I want you to show how these classes are related, right? How these classes are associated, inherited, etc. Right? So that is called class diagram. Right? So that is called class diagram. So this is sequence diagram. Okay, class diagram. So class diagram, it's again a design level thing. Models how the classes are related to each other, and of course what are the attributes and behaviors of each and every class, and of course it include interfaces as well. Okay, interfaces as well. So that is the relationship between classes to classes and classes to interfaces, or interfaces to interface is called, that diagram is called the class diagram. Okay, so it's very important. Okay, now let's try to draw a class diagram for this particular set of classes, or this particular small functionality, tiny functionality. Okay, right. So of course I am not going into detail because still we are not studying the class diagram session, but I am just giving you overview. So now you can see that of course my test A class is just for our testing purposes. Okay, testing purposes. So therefore I am not much interested about test A, but definitely my test A must have access to, right, B object, access to a B object, or my A class can call or invoke behaviors of the B, right? Sorry, behaviors of the so my A class must be able to access the behaviors of the B class. Okay, Now how do you represent that concept? My A class can call behaviors of B class, or in other words, A can talk to B. In other words, A can get some service from B. Okay, so the term we use for this, A can talk to B, A can get the help from B, etc. is called A is associated with B. හරි A කියන එක නම් Bත් එක්ක associate වෙලා associate කියන්නේ මොකද්ද association එකක් කියන්නේ මොකද්ද සංගමයක් එහෙනම් සංගමයක් associate එහෙනම් association එකක් තියෙනවා කියන්නේ මොකද්ද පොඩි හුටපටයක් පොඩි කතා බහක් පොඩි ගනුදෙනු ටිකක් තියෙනවා මේගොල්ලෝ අතර ඔව් ගනුදෙනු ටිකක් තියෙනවා තමයි මොකද්ද A can call some behaviors of B right A can call some behaviors of B now how to show that in our class diagram, of course, I have two class diagrams now. Sorry, two classes now. Class A and class B. And now we can see that A can call behaviors of B, right? Of course, if you are given the access, so that means A has association with B. We say that A is associated with B. Okay. On the other hand, if B can call behaviors of A, then we have to draw it other side, other way. That is something like this. Say this is A, this is B. Now it must be something like this. Okay. B is associated with A. B can invoke behaviors of A. But this is A can invoke behaviors of B. Okay. Right. So that is basic of class diagram, the basic of sequence diagram. Okay. So sequence diagram is a very dynamic diagram. Okay. Right. So I hope you got it. Okay. I hope you got it. What is mean by message passing? What is mean by message passing? Okay. Of course, still we are learning what is by message passing. Later we will be learning what is a sequence diagram, what is a class diagram, what kind of things we can represent in class diagrams, etc. Okay, right. So any questions on message passing? What is a class, what is an object, what is message passing? Any questions? I am going to give more examples and explain it if you have any questions, because this is the most important thing, right? Having a sound understanding about the basics of what is message passing, etc. Right. So now we know what is an object, right? So what is a class, what are the attributes, what are behaviors. Of course we are not using these attributes yet, but we are calling the behaviors of other objects, and we are calling the behaviors of our own object as well, right? So now you have a bit of idea about, of course, very good idea, because you have done this in semester 1 under programming, but this is sort of a quick revision where we want to understand that as a very abstract or as a design concept. Okay, right. So that is the concept of class, concept of object, concept of attributes and behaviors, and of course which is something related to that, that is messaging. Okay, right. So we know that if you want, for example, before calling this behavior, we could have set a particular property of B as well, right? For example, we could have set B dot B1 equals say 10. So maybe if it is a count object, we are setting the some sort of parameter, like say what is the current interest rate. Then only maybe we are just calling the add deposit behavior, something like that. I'm just giving you a practical example. Okay, so you can see that we can refer to their attributes, we can call their behaviors. Okay, we can refer to their attributes from outside, we can call their behaviors. Of course, we can refer to our own attribute as well. For example, this behavior 1 could have access this attribute a1 also. Okay, so for example, it could have set a1 say equal 12. So then only it is called in the behavior 2. Maybe the behavior 2 is also referring to a1. So that it maybe that is why you want to set it. So likewise, you must have very serious understanding about this message passing and what we can do, what we can't do, etc. Okay, right. Now we are done with the basics of object oriented. So basically this is the basis of object oriented: the concept of class, concept of object, the concept of messaging. Okay, and of course the attribute and behaviors of an object or class. Okay, right. Now let's move on to our object oriented concepts. Okay, what are the 4 concepts? Abstraction, encapsulation, inheritance, polymorphism. Right, so if you know those 4 concepts also, then you are pretty much done. Okay, you are pretty much done. Okay, so now let's see, take one by one. Abstraction, right, encapsulation, inheritance, polymorphism. Now remember this, we have very definite objectives in this class. Okay, so that is, say if you are really interested in moving to the software field, because this is a software analysis and designing. Okay, semester 1 it's programming, semester 2 databases, all are related to software development. Okay, nothing else. Say the first idea is, after getting your BIT degree, or maybe just after getting your higher diploma, if you are really seriously want to get into the software development field, okay, get into the software development field, you have to do 2 things. Number 1, you must be able to get an interview, face the interview and get the job. Okay, so that is number 1. So I'm talking about genuine people, right? So I'm not talking about the dirty people, right? Petty people who go behind the back doors, right, to get some opportunities. No, genuine people, right? So they apply for the jobs, they face the interviews, they get their jobs, right? So they don't beg their jobs, they don't, right, so what is called loot or rob their jobs, so others jobs or others money. Genuinely apply for the jobs, get the interview, face the interview, get the job. So that is your number 1. Number 2 is, just because you get the interview, get the job, it doesn't mean that you are going to be a successful professional, right? Maybe after you get into the work, you might find that, okay, it's too complicated for me, right? I don't understand, I really don't understand what is happening in this particular software, so therefore I can't do a productive, I can't contribute to this organization. So that is, again, you must not get into that as well. You must be able to get the job in a genuine manner by facing exams. You must be able to go and do the work, right? So that is the objective behind these particular classes. Okay, nothing else, right? Not because you want to enframe your BIT degree somewhere in your house and show it to the each and every relations, etc. No, that is not our objective. Okay, that is not our objective. Oh, get that certificate and show it to the government and beg for some petty money. හරි ඒව ජොබ් කියන්න බෑනේ. එහෙම ජොබ් ගන්න නැත්නම්කට ජොබ් ඉල්ලනවා නේද? ඒව natural opportunities නෙමෙයි. So no, okay? So that is, keep it in mind. Okay, right. So now object oriented concepts. The first concept is called abstraction. Now we are going to look at it in a practical manner, right? Bit of coding level. Okay, abstraction means when we model the minimum essential. Okay, that's it. Of course, I don't want to explain it in code level. For example, okay, of course, if I want to demonstrate it in code level, of course this is not a very good example to do that, because A, B are just in a way A, B are too abstract to explain you the concept of abstraction, right? It's too abstract. Okay, so if I want to explain you the concept of abstraction, so I have to come up with some real world scenario, right? Not A, B, C, etc. Okay, so let's say this is the exact example I did when I explained you the object oriented programming in your semester 1 also, account class, or you can use anything else. Okay, now when you model the account class, right, this is a bank account. Okay, just give me 1 minute. Right, so when you model the account class, you have to model the concepts or the attributes and behaviors related to account class, right? So the abstraction means when you model something, you have to model the minimum essential, avama atyavashya, right? You have to model the minimum essential, nothing else, nothing more, nothing unnecessary. So that is called abstraction. Of course, abstraction has different meanings in different contexts. This is the basic meaning of abstraction. Okay, so then you have to think, okay, what are the attributes related to account, what are the behaviors related to account, right? What are the essential attributes and essential behaviors? Let's model it. So that is your design or analysis. Then when you're coding, you transform those into variables and methods. Okay, that's it. Okay, now let's first model it as a class. So I'm not explaining what is mean by abstraction, the first concept in object oriented. Okay, so model the minimum essential. Say this is a class called account. Now I want to model the essential attributes, essential behaviors, nothing fancy or nothing extra. Okay, so obviously your account need to have account number to uniquely identify it, right? Not maybe, really, that means surely we need to have the balance, because everyone is interested about the balance of your account. Okay, for me those are the two main things, but additionally I'm interested in something like interest rate, right? Interest rate as well. Those are the three minimum I like to know, but of course depending on your requirements you might need few more attributes. Okay, you might need few more attributes. Okay, so now can you now again I need you to start thinking, right? I gave you three possible attributes, what I think as sort of minimum essential. Okay, account number, balance and interest rate. Can you come up with another possible attributes? Of course, for me these are good enough, but maybe another one or two that you think that still those are also part of the minimum essential.
Account type.
Yes, definitely.
It's current to.
Yeah, one is account type. What is the second one? What is the other one you mentioned? Definitely account type is a very important. Actually, I miss it. What is the other one you mentioned?
No, I just mentioned one.
Okay, you mentioned one. So that is account type. Anything else anyone want to mention? Other than that account type?
Account holder's name.
Yes, account holder's name. So that is something I was looking for. Right? That is something I was looking for, because I know that most of the time you will give, one of you are going to give that answer. Right? One of you are going to give that answer. But I agree with you, account type. Right? Account type or just the type. But I don't really like, of course I can't say I don't really like, but I prefer not to have account holder's name here, right? Can you or someone else explain what might be the idea behind or my thinking? Of course, I have more experience than you in software design, software program design, software design. So yeah, now I am helping you to quickly come up to that level. So why I am saying that I prefer not to have account holder's name as attribute in account class. What might be my thinking?
Because it breaks abstraction, the idea of that abstraction.
Why? Why do you think that account holder's name is not important for account? Whenever you take your account that credit your debit card number or whatever, everywhere you can see the account holder's name, right? Even your account, that book, passbook, you can see your account holder's name. So this subject is taking you to the next level of having that the designer's mindset and think whether which is better. Of course, two things, you may be able to design it in this way or that way, but you must know, okay, which one is the better way. Anyone? Rather than having account holder's name here, can I design it in a different way, a better way?
We can have a link to the on account holder
We can have a
link or something like
oh,
that.
link or yeah. So that means, let's, rather than having account holder's name here, why don't we have another class called account holder or customer or whatever. Customer can have many account, and there we can have the customer name, and of course then not only customer name, right? So we can have the customer's contact number, right? His date of birth, maybe his NIC number here, because those are related. Now you can see customer name is not something directly related to account. It is something to do with the customer. Okay, it's something to do with the customer. So abstraction means when you model, you must model absolute essential things. If it is not really essential to this one, but it is just part of another thing, it must be they are not here, right? It must be they are not here. So the best way to design this is have the another class called customer and have the customer name, his NIC number, etc., contact number, etc. here. Then still, yes, your account must be able to access those information, or at least your account must know who is the holder, right? Who is the customer for this particular account object. So therefore, the better design is you can have a separate class like this and make those two classes associated, right? So association, right? You are going to learn these things when you're doing the class diagram, but already I have mentioned it, right? So whether now you can see that account must know who is the customer. So that means something like that. Okay. And also, if you really think about seriously, if maybe someone comes and give you a customer name or NIC number, sometimes you want to find, are there any accounts for this particular customer. So that means customer must be able to get some information about accounts as well. Now it's a bi-directional. So bi-directional things are represented in class diagrams as no arrow, right? No arrow. If it is unidirectional, arrow like this or this. If it is bi-directional, just a line. So therefore, a better way of doing that is have association between customer and account. Okay, right? So therefore, I am not going to introduce, of course I am not going to model the customer class here, but just few things related to account. Okay, just to explain you that now why I eliminated customer number from the customer name from the account class. It violates the abstraction. It violates the concept of abstraction. Lot of people have no idea about what is abstraction. That means they are not. They think that it's all about inheritance and polymorphism. No, abstraction is the number one. Okay. Right, so now let's model few attributes. Some really important one. Say string, say ACCT number, just to make it a little bit short, and maybe double balance. Okay, balance. And also this is something that with experience you will understand, right? With experience you will understand. I will not even going for account type as well, right? Account type as well, because I can use the inheritance rather than that. Okay, for example, I can create account class, then I can create a savings account class, current account class, subclass in the account class. Maybe a subclass in the savings account class, I can create a super savings account class, children savings account class. So therefore I don't want to go even for the account type as well, because I will get that functionality through inheritance, right? Inheritance. So the account holder's name through association, account type through inheritance. Now you can see that you have to use those. Just because you know what is inheritance doesn't mean that you are capable of coming up with the designing of a software. Okay, right? So you must know these tiny things, the thinking behind that. Okay, thinking behind the how the software engineers, how the designers think and come up with the best solutions. Okay, right? So that is why you need at least 10-15 years of experience to become a software architect. Okay, so we are just giving the startup of that your career, right, in this particular subject. Okay, right? So now I have the account number and the balance, but maybe interest rate, right? Because again interest rate will be specific to different accounts, but maybe this is just a general idea or general value. Okay, or the if it is a default sort of account. Okay, say double or maybe float interest rate. Okay, so now I'm explaining the concept of abstraction using this account class. Okay, right, now I'm going to write some minimum essential behaviors, right? So what are the minimum essential behaviors of a bank account? Can someone tell me? Just the naming. Deposit,
withdrawal,
withdraw, what is that one that you really like to happen to your account? If that is not happening, you don't like to deposit sorry?
overdraft,
No, overdraft is not a very good thing to happen, right? That means you are taking money more than they are. Of course, overdraft is a behavior. Sorry?
Get balance.
Get balance. Of course, that is also sort of behavior, but there's something that everyone is really interested about your account, right? You are very excited about that. What is that? Of course, overdraft we can apply. It's sort of something related to withdraw. Overdraft. So I'm really interested about add interest, right? Add interest is a behavior, right? Add interest is a behavior of account that increase your balance, right, over the time, right? So let's write the code. Void deposit course, if you are deposit, you have to say what is the amount. Let's say double say amount. Now what is the business logic? Your balance must be incremented by the amount. Balance plus equal amount, or you can just say amount equal amount, sorry, amount plus equal balance, or simply you can say amount equal amount plus balance. Okay, now you know what is going to happen to the withdraw method. It is minus, and of course add the interest method. Okay, so here you don't need any parameter because you have the interest rate, you have the balance, right? You can do it. So balance equal balance plus balance into interest rate. So that is balance plus equal balance into interest rate. Of course, interest rate has to be set up. Right? Interest rate. So let's say interest rate is 0.1, or I could have set it in the float, means if here we are using double everywhere, right? So therefore let's have the double for this one also. Right, so those are the minimum essential methods I can think of. Of course, one other possibility is overdraft. Right, so now you can see I have modeled the minimum essential attributes, the minimum essential behaviors, or the methods. So that is, I have complied with abstraction. Of course, I prefer to have the customer as a separate class rather than having customer name here. Okay, otherwise I am violating the concept of abstraction. Okay, right, so that is abstraction. Okay, so if you have any doubts, you have to ask again. I can explain it again and again, as because these are the critical things. Okay, these are the critical things. Okay, right, so the number 2, second concept, encapsulation. Okay, encapsulation, second concept of object orientation. Right, so what is encapsulation? Again, we have to think in a very serious manner, right? Very serious manner, not as a grade 5 student or ordinary level ICT student. This is degree level. Right? This is degree level. Right. So the encapsulation means very simple. The term or the literal meaning is encapsulation. Put into a capsule, right? Put into a form into a capsule. Capsule එක කියන්නේ මොකද්ද? කරලකට වාජනයකට container එකකට තමයි capsule එකක් කියන්නේ. අර බෙහෙත් කරල් වල තියෙන ඇතුළේ බෙහෙත් තියෙන්නේ. So that is encapsulated. encapsulate කරලා තියෙන බෙහෙත්. encapsulate කරලා තමයි බෙහෙත දෙන්නේ ડોක්ටර්. ඔයා encapsulate කරපු බෙහෙත් තමයි බොන්නේ. හරි, ඒක encapsulation එක කැඩෙන්නේ බඩේදී. සමහර බෙහෙත් වල කරල කැඩෙන්නේ ආමාශයේදී. ඒක ආමාශය දුරා ගන්න ඕන නම් සමහර කරල් දිරවන්නේ ආමාශයේදී නෙමෙයි ඔයාගේ බඩවැල් වලදී. මොකද ඒවා සමහර බඩවැල් වලට නම් ඔයාගේ ඒ බෙහෙතෙන් ප්‍රතිකාරය දීලා තියෙන්නේ. ඒක පොඩි තුවාලයක් තියෙන හොඳ කරන්න වගේ නම්. මේක උරා ගන්න ඕන. මේක තුවාලය හොඳ කරන්න බෙහෙතක් නම් මේක බඩවැල් වලට උරා ගන්න. මේක ආමාශය උරා ගත්තම මේක බඩවැල් වලට යන්නේ නැහැ. So that is why we have sort of a that kind of a coating. So that means it's encapsulated, right? It's well enclosed by some sort of a structure. Now what is so same thing when it comes to object oriented programming. Encapsulation means put it into a structure, right? Put it into a structure. So it's very easy. Put into a structure or well defined structure is called encapsulation, right? So again someone will ask, why do you want to encapsulate? There are a few reasons. Okay, number one is, when you encapsulate something, when you put it to a structure like class, okay, in designing something like this, in coding something like this, you can see class, account, these are also sort of encapsulation, right? So this starting bracket and ending bracket, so encapsulated, all your attributes and behaviors are encapsulated into a class, right? Remember, that is the difference between object oriented and structured programming. In structured programming, data and process is two separate, they are not encapsulated. But in object oriented programming, your data and behaviors or attributes and behaviors are encapsulated into one single unit called class. Okay, right? So I hope you got what is mean by encapsulation. Put it into a very well defined structures. Okay, right? So when it comes to encapsulation, okay, so creating a class or designing class itself is encapsulation, and sometimes we even writing a method is also encapsulation. Okay, but when it comes to encapsulation, there's a special case of encapsulation as well. Encapsulation means in general put into a structure. Okay, so that is good enough. But there's a special case of encapsulation called, how do you call that? Can someone tell me? The special case of encapsulation is called? Any idea? How do you call that special case?
Data hiding.
Yeah, data hiding. It's called data hiding. Data hiding is that special case of encapsulation. Okay, that special case of encapsulation is called data hiding. Right. So now, have we done the data hiding in this class? Yes or no? Very straightforward answer. Yes. Yes, this is encapsulated class. But have you done this special case or the stronger form of encapsulation, that is data hiding, in this class? Yes or no?
No.
No. No. Right? So data hiding means you don't allow other class objects to access your data. Right? So that is called data hiding. But now you can see that if I have another class like A or whatever, say let's call it test account. Say I have main method. I can create account class. Of course, classes are there to they are available to make objects out of that. That is why we say class act as a blueprint or factory. Of course, if you can't create objects, why do you need a class? Okay, so now I can, now you can see I can set the balance. A dot balance is, let's say, 10,000. So that is not data hiding. You are changing the data directly, right? So you are supposed to use messaging, right? Messaging के concept आती है उन्हें मेरे दी उन्हें में data access करना क्या अरे right? Messaging is calling the behaviors, not accessing data. So therefore this is violating the data hiding principle. Okay, so data hiding means your class must not expose your attributes directly to other parties. So how to do that? Make those private. Make those private. Now this is not allowed. Now you can see red. You can see red. You are not supposed to do that. So that is good. Yes, we are not supposed to do that. We are not supposed to do that. This is terrible thing to do, right? You can't go to the bank and say set my balance to 1 lakh, right? So that is not possible, right? So they will say no, we can't do that. Right? So we can't do that. If you want to make it 1 lakh, okay, say this is 1 lakh, they will say okay, now your balance is 25,000, deposit 75,000, then it will be 1 lakh. But we can't change your balance. If you have to show your behavior, then your balance will be changed. Okay, right? So that means what is data hiding? Hide your data and let those be accessed or changed only through behaviors. That is called data hiding. Okay, now I'm going to make it data hiding. Yes, it's data hidden. Now if you want to change your balance, either you have to deposit or withdraw or add interest. As simple as that. Okay, and of course now no one can read or change the interest rate as well. Okay, no one can read or change the interest rate. So therefore because it's private, okay, but there someone will be interested in reading the interest rate, or sometimes you want to change it due to some business policies, government policies, etc. Okay, so now we want to change that also. So therefore, but still it is not directly accessible, but we should be able to access it through some behaviors. So that is where you have this getters and setters. Say void set interest rate. So if you want to set the interest rate, obviously you have to set it as a variable, a parameter. Say double, let's say rate. Now that means, okay, let's call it interest rate. Why do we want to call it rate? And now we know that this interest rate, how to refer to that? This dot interest rate equal. Now if you are not referring to this, if there is a parameter that or local variable, that is what we are referring to. Okay, right. So we are not referring to that. Now interest rate is not exposed directly, but you can set it through a behavior, right? Or if you read it again through a behavior, say return double get interest rate, and now when you call the get interest rate, of course you are not supposed to give that, but we are going to return the interest rate. Right, so that is the get method. Similarly, if you want, you can have get balance as well, but don't have set. Make sure you don't have set balance. Maybe get balance. Right? There's no rule saying you must have both. No, there's nothing like that. Okay, so let's say I want to check the balance. If I want to change the balance, of course I am supposed to call deposit or withdraw method. Okay, or the bank will call add interest. Okay, right. So now I have set interest rate and get interest rate. Now we are going to have another method called get balance. So that means it must return double. We can say return this dot balance. So we are done. Of course, we are not going to give set balance because that is violating your business rules. Okay, you are supposed to show withdraw and withdraw or deposit behavior if you want to change the balance. Okay, but if you want to get the balance, you can call this. It is going to give you that instance variable. Okay, right now we are pretty much done. Right? It's a well encapsulated and also well data hidden class. Right? Well data hidden class. This account class. Okay. Right. Now, how many concepts we have discussed? Abstraction, then encapsulation. Okay. So the third one is inheritance. The fourth one is polymorphism. Then we are done. Okay. So remember, when you go for, if you go for a software developer interview board, they are going to, the interview is going to be really tough. Right. I'm not saying that is impossible, but it's fairly tough. Okay. Why? They want to get only the people who have that capacity, caliber, right? People who are fearless. Okay. Right. So therefore, definitely they are going to ask what is abstraction, what is encapsulation, what is inheritance, what is polymorphism. Those are the hot topics when it comes to interview questions. Okay. Because unless you know these concepts properly with lot of confidence, you will not be suit into the real world software development culture they are having. Okay, right. So now we have discussed encapsulation and abstraction. So the other two are inheritance and polymorphism. Okay, now let's see what is meant by inheritance. Inheritance. Just give me 1 minute. Right. Now let's move on to the third concept, that is inheritance. Okay, but we are going to look at it in a very serious manner and also related to analysis, design, and development. Okay, inheritance. So we are done with this. We are done with this. Right. So what is inheritance? So can someone give me answer according to your understanding? So don't worry, right? It may not be perfect and it's very difficult to give perfect definition to inheritance, but reasonable answer. Because if you go to the interviews and if they ask, can you explain what is inheritance? If you have never thought about that, how to give that, express that kind of a concept, and now you are in trouble at that point, right? So don't go there and have that trouble. Try those things here and learn it and be prepared. Okay, according to your understanding, how do you explain inheritance? So you have to explain a little bit of why and how, or the idea behind inheritance. Of course, you have to think and talk now because it's a serious concept. No one? Okay. So because it's a little bit serious, right? So you are a little bit hesitant to give answer. Right. So inheritance means creating a creating a hierarchy of classes or designing a hierarchy of classes like this it don't necessarily go into this level, maybe just one or two subclasses. Of course, you can have something like this also. Okay. So the first part is inheritance is creating a hierarchy of classes. Second part is such that classes below the hierarchy or the subclasses get access to the certain attributes and behaviors. So that is called inheritance. Okay, creating a hierarchy of classes such that the classes below the hierarchy get access to the some of the attributes and behaviors. Not all. For example, if your superclass has a private method, definitely you can't call that. Okay, because private means private, not even our children. Right, so that is inheritance in programming, in analysis and design. Okay, inheritance. Right, so my next question is, why do we need the concept of inheritance in programming? Why? Now what is done? Now we are into why. Anyone? What is the idea behind, or what is the purpose of inheritance? So in a simple word, if someone want to explain this in a very simple one word, the simple answer is reusability. Right? Reusability. That is the idea behind inheritance. Okay. Right. So how does this work? Of course, you need to have some sort of class hierarchy. Right. So let's introduce something called savings account here. Savings account, I'm going to say that it is extend from account. Okay, extends account. Okay, so that means my savings account is a subclass of account. Okay, right. So now let's have maybe one more attribute. Let's say something like add bonus interest. Let's say add bonus. Okay, why is that? Void curly bracket, right? Right, so this is one particular behavior, add bonus. So that can be done in savings account, not in normal accounts. Okay, not in general account. So let's add some functionality. Okay, so what we are supposed to do, add bonus. Of course, you have to tell me what is the bonus amount. Let's say double, let's say bonus. So I am going to do what I'm going to, because my subclasses have access to all non-private attributes. Okay, so unfortunately when we're adding the bonus, we want to add bonus to the balance, right? So my balance, is it private or what? Balance is private. So that means private means even your subclasses or your children cannot see it. You try to access that, right, somewhere here, it's not going to work. Okay, but what you can do is, right, so now let's try to do that. Say balance, what you're supposed to balance equal or equal balance plus, so plus equal bonus. Okay, balance plus equal bonus. But now you can see that balance you can't access, even your subclass cannot access, right? Subclass cannot access. Why? Account, in account class balance is private, right? Private means only you can access, not even your children, right? Not even anything in your package, only you. Okay, so therefore this calculation is not allowed here, but of course you know that you can call the, right, get balance method to get the current balance. Okay, so of course, because savings account is subclass of account, by default your savings account has all those access. Okay, so therefore what I can do is I can write something like this. Say, so we want to add the bonus. So we can call something like this, set bonus, sorry, not set bonus, set, there's nothing called set balance as well, remember, there's nothing called set balance. Of course you have this deposit, but this is not deposit. Okay, this is adding bonus. What can we do? Because we don't have access to the private variable balance. Okay, but we want to add to that. So then of course, because since I want to preserve the encapsulation or the data hiding as well as the abstraction, etc., what I can do is I can expose the balance maybe using a public getter method. Okay, so let's do we already have it, right, get balance, but unfortunately we don't have the set balance because usually we are supposed to go through the rules. Okay, but we can call the get balance. Okay, let's call the get balance first. So get balance plus the bonus. Okay, but it has to be assigned to the balance, right? Assigned to the balance. But now we are in trouble. If you try to, of course you cannot access the balance variable, that is why we call it get balance. So then of course, if now we are going to update this, right, we are going to update this. So then one solution is, here let's have set balance as well other than deposit and withdraw. Set balance. Okay, so now this is void and this is where we need parameter. Say double amount. Now what we are supposed to do? This dot balance equal amount. Call it balance, right? Why don't you have the same name? Balance. So what you're supposed to do now? This dot balance equal this balance. So that is how you set the, or add. Now we can use the set balance method in the add bonus class. So the add bonus behavior. How to do that? Get balance. It will give you the current balance plus balance into bonus. Balance into bonus. But we have to do that. We have to set that to the balance, right? So therefore what I can do is I can say set balance, right? So what you're supposed to do is do this, then you are going to get the answer. Bonus right? So we have the get balance will give you a balance, right? Okay, why do then we have to increment it by balance into bonus, right? So now we got the bonus interest. Okay, right, now let's go into the test account class. Of course you can't set the balance like this, but you can set like this: a dot set okay, why there's no get set balance. Okay, this must be a. Okay, set balance maybe not set balance. Okay, I have the account class, I want to get balance. Okay, sorry, get balance, so that is going to give you the balance. Okay, of course if it is returning something, you better assign to variable or just put it into SOUT. Okay, let's put it into SOUT. Okay, so that is right, so that is how you get the balance. Okay, how you get the balance. Right, now I want to call that add interest, or the sorry, add interest is available. Okay, add interest is available. For example, a dot add interest is available because add interest is something your account class has. Okay, and of course deposit, etc. Okay, let's do a deposit, say 1000, and let's do it. Okay, I will create not an account class, rather, right? So now let's create another class. Okay, let's do a deposit and withdraw maybe 500 or maybe 200. Now I want to print the balance. You can say a dot get balance. Obviously now this answer is going to be 800, right? 1000 minus 200 is 800. Okay, right? So okay, why it's 0? Can someone tell me why is that? A is account, we deposit 1000, withdraw 200. Now the balance is why 0? Have I done something wrong? Deposit plus balance, amount equal amount minus balance. Can someone detect the error? Then I am printing the balance. Why it is giving 0?
It's updating the
Sorry,
parameter value.
sorry, I didn't get it.
It's updating the parameter value. Amount is the parameter cost, right? It's updating the
Deposit method.
parameter.
Yes, yes, correct. This, when we say balance, no, that is okay. So when we say amount, oh, that is okay, right? Amount, sorry, balance plus equal amount. Yes, sorry, okay, balance plus equal amount. Yeah, sorry for that. Next one also I have that issue, not the amount, it's balance minus equal amount. Yeah, sorry for that. Okay, right, so this one is okay, balance plus equal balance into interest rate, right? And set interest rate is also correct. Okay, now it should work again. Say test account, I must get 800. Right, previously 0, now 800. Now let's create a class called test savings account, because we have savings account also, that is to test the inheritance. right? So I'm going to copy test account class, the main method. Right, so let's create a savings account. Right, so we are now seeing what is the balance, then we are depositing, withdrawing. Now in this account test, I can't call something like a dot because only savings account has the add bonus, right? So I can't do something like this. A dot add bonus, something like 500 or whatever. So this is not allowed in account test or the account object because account object doesn't have a add bonus method. Okay, but definitely savings account has add bonus, right? You can see add bonus, others are inherited, and new one called add bonus. So therefore we can call add bonus now because this is savings account, right? Because it has inherited deposit and withdraw and add interest, but it has its own behavior called add bonus as well. Inherited most of the stuff, plus it's introducing one more or few more attributes and behaviors. Okay, so that is inheritance, right? So you don't have anything called deposit or withdraw in savings account class, but still deposit and withdraw is available because you are inheriting from account class. Okay, right, so that is inheritance. Okay, inheritance. So why we like inheritance? When we have inheritance, it's called reusability, right? Your savings account is already reusing basic features of account. Okay, so inheritance promote, right? Inheritance promote a concept called, right, a concept called open close principle. Right, so this one, just give me 1 minute. Okay, I will close it and take it back. Okay, so inheritance promote reusability, right? Inheritance promote reusability. So now I explain you what is or how it is done. So in tax savings account, this deposit and withdraw are inherited from the account class. They are not in the savings account class. You can see this is account class, so those are inherited, right? So that promote code reusability, right? We don't have to write everything, we just have to override that maybe at some futures. Right, now we are done with abstraction, encapsulation, inheritance. Okay, so the final concept is called, the final key concept is called polymorphism, right? Polymorphism, then we are done. Right, polymorphism. So if you have any questions on inheritance, you have to ask, right? I'm always willing to explain it again, right? So let's move to polymorphism. Okay, I keep getting some errors here. Right, polymorphism, that is our last concept. So poly means many, morphism means forms. Your object can take many forms. It's not any form, many forms. If someone asks what are those forms, the answer is its own form or any of its supertype form. So that is very important. That means my savings account can act as a savings account, and also it can act as an account. Okay, my dog can act as a dog as well as animal, because dog is animal. Okay, right. So polymorphism means your objects can take its own form or any of its supertype form, right? Own form or supertype form, right? So that is called polymorphism, right? It can take its own form or supertype form. So that means my account class can act as a account class or savings account class, or rather more precisely, an account object can act as a account object or even savings account object. So that is called polymorphism. Okay, right. So another way of defining polymorphism, now the first way approach is more technical approach, more serious approach when it comes to coding. But there's a sort of a high level definition also when you are discussing something called polymorphism in real world software development. We use this under analysis, not as a design. So that is, so this is the definition one. Of course, this itself is good enough, but there's another way of doing this as an architect or designer's mindset. That is, polymorphism is ability of an object to respond to a message differently, but the message is the same. For the same message, objects or different objects may behave differently. So that is again polymorphism, right? So ability of object to behave separately for same message. This is not by mistake or something. This is deliberately we need that functionality, right? For example, my dog can act as a dog as well as my dog can act as an animal as well, because my dog is animal. Okay, so that is called polymorphism. Okay, polymorphism. Right. So now we have discussed abstraction. Of course, we discussed the messaging, class, object, attribute, behavior, right? So then abstraction, encapsulation, and of course inheritance and bit of polymorphism. Not much serious coding level polymorphism, okay? Because we are going to keep that for the next class, okay? So dynamic binding, late binding, I want to explain to you because I want to explain it with proper context again, because it takes a little bit of more time, right? So we'll be discussing that and these things next time and finish this topic.